Hello, this is Bruce McIntosh presenting Visual-Textual capsule routing for text-based video segmentation, co-authored with Kevin Duarte, Dr. Yogesh Rawat, and Dr. Mubarak Shah. We are all from the Center for Research in Computer Vision at the University of Central Florida in Orlando. Our task is, given a video, localize an actor by its type and the action it is performing, and do this based on human-generated sentences as queries. For example, below on the left, we have the query, dog is walking around red cones. So only the dog highlighted on the right should be chosen, since the dog on the left is sitting. The example on the right shows the expected response for the same video when given the query, a woman in green top standing on the left. You can't see it here, but in the video, the person on the right is walking along with the dog. We perform our task on the A to D dataset, which consists of more than 3,500 in-the-wild videos, each containing one or more actors performing an action. The dataset was extended with the addition of over 6,500 human-generated queries by Gavrilyuk, who first proposed this task using a fully convolutional network with dynamic filtering. Our approach is to create a set of capsules from the video input and a set of capsules from the query sentence. We leverage the fact that the same entities exist in both sets of capsules and use routing to find the similarities between these entities. A high level of agreement between both capsule types at a given location in the video indicates the presence of the actor. Now for a closer look. The process for generating video capsules begins with in-frames being input into an i3D three-dimensional convolutional network. From the resulting feature maps, 8 capsule types, each consisting of a 4x4 pose matrix and a single activation, are formed at each location representing the spatio-temporal features there. For the queries, each word of the sentence is converted into a vector using the word-to-vec model trained on the Google News corpus. These vectors are then passed through 3 parallel stages of one-dimensional convolution with various kernel sizes. The results are max-pooled to form a single vector from which 8 capsule types, similar in structure to the video capsules, are formed. The video and sentence capsules are combined so that there are 8 each for every spatial location. Each capsule learns a transformation which it uses to cast votes for a higher level capsule, which we call actor capsules, and which correspond to the 7 actor classes plus an empty class. A high activation for a particular type of actor indicates its presence at that location. Once the network has its class prediction, the pose matrices for that class move forward into the upsampling network, while the pose matrices of the other classes are masked out. The upsampling network consists of several three-dimensional convolutional transpose layers that create frames of foreground-background actor segmentation. The network is trained end-to-end using binary cross-entropy loss based on the segmentation ground truth and a classification loss. Our network outperforms previous techniques for segmentation and has a unique capability of producing a segmentation from every input video frame. Here we show the quantitative results for the A to D dataset, where our network outperforms previous methods in all measures, doing particularly well in mean average precision. Here are some qualitative results from the same A to D experiment. The results for 3 different queries are shown for the same set of video frames. Results from the previous method are shown in the middle row, and results from our network are shown along the bottom. Our network shows a finer level of detail in the segmentation and does a better job of distinguishing between which dog is indicated in each query. Here is an example of the network's discriminative capability. For the same video clip, we provide several different queries. On the far left, we refer to a car, which is one of the understood actors, but since it is not present, there is correctly no segmentation result. The next 2 queries correctly find the 2 running dogs and the man walking, while the final query correctly shows no result for a man standing. Many of the queries included other descriptors such as color and relative location in addition to actor class and action, and we see examples where the network has understood these as well. Thank you for watching this presentation. Please take a look at the paper and supplementary materials to see additional experiments, ablation studies, and analysis. To support our experiments, we have created bounding box annotations for all frames of all the videos in the A to D dataset and are making them available to the community.